So I'm going to show you how to do a linear programming problem. I have other videos that will show you how to solve a linear programming problem with word problems. So here's the general idea for this one. You're given a function, and this function is what you use to find either the maximum or more minimum value of a group of inequalities. Okay, so you're going to graph this system of inequalities. You're going to find where they intersect. You're going to plug those points of intersection in for x and y and find the maximum, the one that gives you the maximum value. Okay, so let's go ahead and do that. Let's start with x is greater than or equal to 0. So you graph the line x equals 0. So that's the x is always 0, y could be anything, so that actually is your y-axis. Okay. Whoops. There we go. So that's this line right here, and your solutions are to the right of that line. X is greater than, or the values to the right. Okay. And I'm just going to label this is x and this is y. Okay. So now let's graph y equals 0. So these are actually all the values where y is 0, so x can be anything, and that is actually along your x-axis. Okay, and your solutions is y, or your inequality is y is greater than, so that's going to be, would shave above. So y's are greater than above the line, they're less than below the line. So it's going to be in the positive x and positive y in the quadrant 1 here. Okay, now let's see, let's go ahead and look at the next line. And that's going to be 4x plus 2y equals 52. Now I like to just kind of look at my x and y intercepts. So when x is 0, I replace x here with 0, and then you get the equation 2y equals 52. So you solve that equation by dividing both sides by 2. 52 divided by 2 is going to give us 26. Now you do the same thing, replace y in this equation with 0. 2 times 0 is 0, and you get the equation 4x equals 52. So you divide both sides by 4 here, and you're going to get 52 divided by 4 is 13. Okay. So if we're going to graph this, let's say that let's make our x values 2, 4, 6, 8, 10, right? 12, and we'll go by 5s because it looks like the y values are bigger. 5, 10, 15, 20, 25, 30. Now I'm just going to kind of not stress too much about this and just kind of do the best I can on my graph here. So 13, 0 is going to be this point right here, and 0, 26, that's going to be just above 25, so right there. And I'm going to draw that line there, connect those points. And so I'm looking at my inequality, and I look at this in terms of y. Since this is a positive value, I can use my shortcut here. This is y is less than. Y is less than would be shaded below the line. So I'm looking at something in this region here, right? To the right of the blue line, above the green line, and below the red line. So far it's my solution's in here, but I have one more inequality to add to this. So let's calculate that. So we're going to have this line 3x plus y equals 36. And then I like to just, again, find my x and y intercepts. When x is 0, right? 3 times 0 is 0, you're left with y equals 36. And I replace y in my equation with 0, and I get 3x equals 36. I divide both sides by 3. I get x is 12. Okay, so let's graph 0, 36, 30, that'd be 35, so 36 is right above there. And 12, 0 is right here. Oops. So we're going to do the best we can with this little line here. And I'm looking for, let's see, my inequality says the y value in front of the y is positive. So this is y is less than, so I would shade below. Remember, if there's a negative in front of the y, then you do the opposite. Okay, so my solution is this region here. Well, better not, let's see. Below the purple and the red line, up to the right of the blue and above the green. So it's that region right here. Okay, and so now at this point, once we've graphed that, what we need from this graph are these points where each of these lines in our solution intersect. So we've got a point of intersection between the purple and the red line, the purple and the green line right here, the green and the blue, right, and this was the red and the blue line intersect here. Okay, and it's just the ones that are on the edge of the boundary solution here. Okay, and like I said before, it turns out that your min or your maximum value for your function that's going to be applied to this system of inequalities is going to contain your min and your max value. So this point is the easiest. Let's write it down, 0, 0. And it's clearly going to be your minimum value here. Okay? And then we can see this value here is the point, that was the point 12, 0. Okay, and then we have this value right here, and that was the point, let's see, that was 26, 0, 26. And then there's one other value that you're going to have to calculate. You're going to have to calculate this value right here. And you're going to do that by taking the red and the purple lines, it's both of these lines here, and finding their solution. And so you remember you can do that by the substitution method or the addition method. Either way will work just fine. I'm going to go ahead and use the addition method here. I see I have a 2y here. If I multiply this second equation by a negative 2y, I'll have 2y and a negative 2y, and those will be able to eliminate each other. So let's go ahead and multiply this, both sides of this equation, by a negative 2. Okay, so we will get here negative 6x minus 2y equals a negative 72. And then we'll just rewrite this equation just the same as it was. 4x plus 2y equals 52. Now go ahead and add those two together. 4x plus a negative 6x is a negative 2x. The y's cancel each other out, and 52 plus a negative 72 is a negative 20. Divide both sides by a negative 2. You get x equals 10. So that's the x coordinate that we were looking for. So we can find the y coordinate by plugging it back into one of your original equations. I'm going to plug it into 3x plus y equals 36. I'm going to replace the x here with 10, so 3 times 10 is 30. 30 plus y equals 36. And subtract 30 from both sides, and you get y equals 6. And so you get the point 10, 6. So we're going to look at these four values here. And let's see, I'm going to go back to blue here. Basically, we're going to take our z function, okay, give ourselves a little space here. Here's our z function. We're going to take each of these values and replace the x and the y with these coordinates and find out which z value is the largest. So if we replace x with 0, we get z equals 2 times 0 plus 10 times 0, and that's just simply 0. Okay. And if we replace the x with 12 and the y with 0, we're going to get 2 times 12 plus 10 times 0. It's going to give us 24. Okay, and then if we take our z function and replace x with 0, we get 2 times 0 plus 10. Replace our y with 26, so we get 10 times 26. Okay, so that's going to give us 260. And then we've got one more to replace the x with 10 and the y with 6, so we get 2 times 10 plus 10 times 6. And that's going to give us 20 plus 60, which gives us a total of 80. Okay, you always want to check all of these. You can usually just skip the 0, 0, obviously. And you can see here that this gives us the maximum value. So your answer is 0, 26. This is the value on your graph that gives you the maximum value for your composition function. So you can see that this is a long process, so take your time and do the best you can. And it's all stuff you've done, and you're just putting it together.